So, Bismillahir-Rahman-Rahim. Our today's topic is instantaneous and average power. Instantaneous and average power, right? So, for example, let us consider a passive linear network considered to be a sinusoidal source. So, let us consider a sinusoidal source. Sinusoidal source, right? And assume that it is connected to a linear network, passive linear network. This is passive linear network. So the source has a voltage, for example, V, instantaneous voltage V, here V of t, and there is a current being delivered to this network, and let this current be I of t. So we are interested in knowing the power. So this is an instantaneous voltage source, and this is an instantaneous current. The power is also instantaneous then. P of t is equal to V of t multiplied by I of t, right? So this is the instantaneous power which is being delivered to this network. Instantaneous power, right? So to further investigate this instantaneous power, let us assume that let V of t be Vm cos omega t plus theta v. This is the phase angle, right? So of the voltage, so theta v, right? Let this call this equation 1. Let I of t, the current, be Im. This subscript m stands for maximum value, right? The peak value. Im, and this is cos omega t, and the phase angle is theta I, right? So before we proceed further, what will be the angle of the impedance here? Angle of the impedance, total impedance, the total impedance of this passive linear network. So that will be the difference between the phase angle theta v and theta I. Okay? So the angle of impedance of linear network will be theta v minus theta I, right? Because if we take the phasor of this voltage and the phasor of this current and we divide them both, so the phase difference of the phase angle will be theta v minus theta I. So that will also be the angle of the impedance of this passive linear network. So this was only a passing remark. We are interested in is the instantaneous power. So P of t, as given here, is the product of V of t and I of t, right? Is equal to, so we can say that this is Vm Im, right? And cos omega t plus theta v multiplied by cos omega t plus theta I, right? But this cos, the product of the two cos terms, it can be from trigonometry. We know that cos A multiplied by cos B, for example, is equal to 1 by 2 cos A plus B plus cos A minus B, right? So for example, if this is A and this is B, right? So we can use this trigonometric identity to further simplify this. So then P of t is given by 1 by 2, and this Vm Im constant remains there. We are just going to replace this with the identical value corresponding to this. So this is 1 by 2 Vm Im, and then cos A plus B. So this is A, this is B. So this is omega t plus theta b plus omega t plus theta I, right? So this is A and this is B, A and B. And then plus cos A minus B now, omega t plus theta b minus omega t minus theta I. So this omega t cancels here, and omega t, both these omega t's add here. So this becomes the instantaneous power is equal to 1 by 2 Vm Im, and this becomes cos 2 omega t, right, plus theta v plus theta I. Do you have any questions? Anybody who has any questions, please do let me know. Roll number 71, please. Yes. All right. So you please turn on your microphone only if you have any questions. If you have any questions, you can ask me, right? So cos 2 omega t plus theta v plus theta I, right? And this term then will be cos theta v minus theta I, right? So this can be rewritten as 1 by 2 Vm Im. I prefer to write this term first because this is constant, right? Cos theta v minus theta I. Vm is a constant, Im is a constant. Theta v and theta I are also constant. So this entire term is a constant term, right? And then plus 1 by 2 Vm Im cos 2 omega t plus theta v plus theta I. This term is the instantaneous term because it involves omega and t. So this is the instantaneous term here. So this is constant term. So this term is instantaneous. And the frequency of the instantaneous power is twice the frequency of the voltage and the current. The angular frequency of the voltage is omega, and angular frequency of the current is omega, and the frequency of this instantaneous power is twice omega, 2 omega, right? So and this term is constant, this term here is constant, right? So we can plot this term also, we can plot this instantaneous power also. This is P of t here, and this is the bias. This shows up here for them, this constant term, and the plot for the for this complete instantaneous power will be something like this. You see the axis is around here, a little bit upward. The axis of should be around here in the middle, right? So this is the axis. The horizontal axis is this is t here, and this is P of t here, but the middle of this sinusoidal term is this line here, almost. And this is the this value here is the this power term, this constant term, 1 by 2. This is this the difference here, this difference here, the height of this line here is given by this constant term, 1 by 2 Vm Im cos theta v minus theta I, and the peak value here from here till here is given by this constant term, right? This is 1 by 2 Vm This constant. This gives the height of the peak with respect to this line, 1 by 2 Vm. So this is the plot of the instantaneous power. This is the instantaneous power that we have, right? And this instantaneous power uh, is the power which is being delivered instantaneously by the source. At one instant it may be being delivered by the source, and at the other instant it may be absorbed by the source, right? So this instantaneous power, the knowledge of the instantaneous power may not be useful, and we need to find out the average power. Of course, the instantaneous power, knowledge of instantaneous power may be applied somewhere, but most of the time will be needing the average power which is being delivered by the source or absorbed by the source. So, do we have any questions till now? What we have learned till here? Do you have any problem related to this? You are all right with this? Let's move on, right? So the average power is the yes. Do you have any questions? So the average power is the average of the instantaneous power over one period. So the average power, if we denote it by capital T, is equal to 1 over the time period and the integral over one time period 0 to t. This is instantaneous power P of t, and we integrate with respect to time. So we know that P of t, we just find out that P of t is given by this expression here, right? P of t is given by this formula. So P of t is equal to 1 over 2 Vm Im cos theta v minus theta I plus 1 by 2 Vm Im cos 2 omega t plus theta v plus theta I. So this is the instantaneous value power that we have. We can put this, substitute this here, and then integrate to find out the average power, right? So P is given by 1 over t, and this consists of two parts, the instantaneous power, so integral can also be divided into two parts. So 1 over t, so this will be 1 by 2 Vm Im, this is of course from 0 to capital T, 1 by 2 Vm Im cos theta v minus theta I plus 1 over t 0 to t 1 by 2 Vm Im cos 2 omega t plus theta v plus theta I, and we integrate with respect to t. So this term here is constant, right? Vm is constant, Im is constant, so theta v minus theta I are also constant terms because these are the phase angles. So cos theta v minus theta I is constant, but this term involves, this is the instantaneous terms and this term is constant. So we can write it like this: P is equal to 1 by 2 Vm Im cos theta v minus theta I, and we integrate from 0 to capital T. This is 1 over t here also, 0 to t and dt, right? And plus this term, this term is constant, 1 by 2 Vm Im, this is 1 over t, 0 to t, and this is cos 2 omega t plus theta v plus theta I dt. And this is the integral of a sinusoidal term. We know that the integral of a sinusoidal term is 0, right? Integral of a sinusoidal term is 0. So this part reduces to 0, this term here. So we are left with only this term here. So P is equal to 1 by 2 Vm Im cos theta v minus theta I multiplied by 1 over t, and the integral is t, and this is 0 to t here, and we are left with plus 0 because the integral of the second term involves a sinusoidal term, so the integral of the sinusoidal term is 0. So this is P is equal to 1 over 2 Vm Im cos theta v minus theta I, and this is 1 over t into t minus 0, so that is left with t only. So this t cancels with this t, so this is 1. So average power is given by 1 by 2 Vm Im cos theta v minus theta I. So this is the average power. When we are given two sinusoids, the voltage and the voltage and the current. The voltage here is Vm cos omega t plus theta v, and the current is I of t is equal to Im cos omega t plus theta I, right? And then the average power is given by 1 by 2 Vm Im cos theta v minus theta I, and the instantaneous power is given here. This is the instantaneous power. And note that the instantaneous, the power, the term for for the instantaneous power, the equation for the instantaneous power also includes the formula for the average power. So instantaneous power is a sum of this average power plus one instantaneous term, this one. And in this plot here, this is the average power here, right? This line here is the average power. So so this phase difference of the phase angle, this determines the average power, right? And we also note that theta v minus theta I is equal to theta I minus theta, the cos of it doesn't matter whether we subtract theta I minus theta from theta v or subtract theta v minus theta I, because the cos of both the terms both the angles will be the same, right? And we can also arrive at this formula using phasors. So average power using phasors. So we can write the phasor for this v of t, Vm cos omega t plus theta v as this here. So the phasor representation is given by V is equal to Vm angle theta v, and the phasor representation of the current is given by Im angle theta I. So this is I subscript m angle theta I, right? So now if we evaluate 1 by 2, for example, V I conjugate complex, so this is equal to 1 by 2 Vm theta V multiplied by Im angle minus theta I, because the conjugate complex of I is Im angle minus theta I. So this becomes 1 by 2 Vm Im, and the angle is theta V minus theta I, right? And if we open it, it will come out to be 1 by 2 Vm Im, and this is cos of theta V minus theta I plus j plus j plus j sine of theta V minus theta I. So you see the real part gives us the average power. So we can write it, the power, average power is equal to 1 by 2 Vm, or sorry, we can write it 1 by 2 the real part, the real